So the key to these unfamiliar Born Harbour style questions is not to look what you have on each of your lines, if I think of each of these as a line, but look at what the change is between the line. So you're looking at the difference, what has changed. So let's look at this arrow here. Well, my calcium and my 2HBr have changed into calcium bromide and H2. My oxygen, my half O2, has stayed the same. So the difference between here and here, which is this arrow, is calcium plus 2HBr goes to calcium bromide and H2. Well, that's this top equation here, isn't it? That's this equation. And so I can say that this first arrow here represents minus 340. We're not looking at what's on the lines, we're looking at what has changed between them. To carry that on then, between my second line, well, my calcium bromide has stayed the same, but half O2 and H2 have gone to H2O. Well, that's the enthalpy of formation of water, isn't it? You're making 1 mole of water from its elements in their standard state. So I can label that as the formation of H2O. On this arrow here, we've got calcium plus half O2 goes to calcium oxide. My 2HBr hasn't done anything, that stayed the same, so I can ignore that. Well, calcium and half O2 go into calcium oxide, that's the formation of calcium oxide, because we're making 1 mole of the salt from its elements in their standard state. Now again, it says in the question here, the formation of calcium oxide is plus 40.2. And this final equation, well, everything's changed, all of that has changed into all of that. That's the bottom equation here, so that's minus 460. Next, we're going to need to use Hess's law, just like we would in a normal Born Harbour cycle. It does not matter what route you take, as long as you start and end in the same place. So we're asked to find the enthalpy of formation of water, so this arrow here. Where does this arrow start? It starts there and it ends there. So Hess's law, I must start and end in the same place, like so. So my route 1, which is my formation of water, is equal to, well, my pathway, my red arrow, is going against this black arrow, so I need to flip the sign. That becomes plus 340. It's going with this arrow, so I keep the sign the same, plus 40.2. And it's going with this arrow, so I keep the sign the same, minus 460, bang it in a calculator, and you'll get minus 79.8, and then the units, kilojoules per mole.